Hi, I'm Joe Markowitz, the blacksmith here at the Wareham Forge. And what I've got here is a short little demonstration of making this particular element, which is one of the uprights for the ongoing Reed Maxwell project up in Manitoulin Island. And this is the undersea portion of the overall conceptual design, which is short to sky. And the individual element is made of a length of 40 inches of a 1-inch wide angle iron that's been flattened, figured into a set of reversal curves, and then the upper portion collapsed to create this quite distinctive stem-like portion. The overall length of each piece here is a little bit longer than the 32 inches that's required for building code, but by making them a little bit oversized, I'll later be able to adjust them to fit in the uprights. Now this sequence you're going to see here is the first heat to making each of the individual uprights. I'm working with a relatively heavy hammer. This is a 1.5 kilo, and I'm using the heavier hammer because I want a soft, mushy stroke. I'm going to show you each sequence both in a wide angle view so you can see my arm motion, and then a second close-up view of me performing the same work on a second bar. So I've got my individual rods heated in the gas forge. This is the first heat for each unit. First, I collapse the bar using a series of strokes that run up and down the angled side, and then even those out by following up duplicate set of strokes on the back, and then do a second set of even strokes to make sure that what used to be the sharp corner of the angle iron has been collapsed down to a relatively even segment. That's one heat. Okay, in detail, the second heat. Again, using a heavy hammer to flatten out the angle iron. Creating a transition from the angled to the flat. And then going over the surface to make sure that the vein is collapsed in a uniform fashion, and then flattening out the bar. So the next step is flattening out the ends using the So with the hand hammer, I'm getting off any ripples from the heavier strokes created by the air hammer. Also evening off the two edges into a gradual taper. So you can see I'm working the center seam as well as the edges. Number one. See, I'm using a series of diagonal strokes. So by the time you got 4 inches of the first one done, so this will give you a close-up of the technique of folding the angle iron into a kind of a teardrop shape to create the stem portion of each of the kelp fronds. And vaguely straightening it. little bit of organic curvature is good down these lengths. Okay, heat 5. Working with the 1 kilo hammer, which gives me a slightly mushier stroke, but at the same time it's still light enough that I can exert a fair amount of control, as you can see here, to actually correct the flat sides of the angle line as it collapses to yield the semicircular profile for the stem. And just, again, getting a somewhat straight shape. So for heat 6, I'll use the rounded side of a farrier's hammer. A hammer that's crowned on one side and flat on the other. Switch to the flat, and I can finish off the last bit of the stem by working up against the curvature, the radius of the anvil with the crowned face of the hammer. I can get a nice transitional shape here between the flat section and the curvature at the bottom. And that completes the stem portion. Now each one of the curved elements, the ripple effect at the top is made of the flat material, is treated entirely different. The hope here is to have a series of irregular curvatures, quite distinctive for each one. And there's a limit to how much foraging you can do in a given step. You can see that the heat's pretty well gone. Where before I was working in pairs of 2, now I'm working in groups. Before I've been working in groups of 3. Now I'm only working 2 rods at a time, because the irregular shapes are fairly difficult to get inside of the gas torch. You can see I'm also working with a 1,000 gram partially crowned hammer. I've got the curved side of the hammer that I'm actually doing most of the shaping with, so that I get nice irregular shapes, curved shapes without sharp edges. Each piece needs to be somewhat straight down its shaft length, though not perfectly. Ideally, the line down the center will allow this to be fitted into the frame and still maintain a relatively straight line. So this shows you a number of the completed elements laid out on the shop floor in roughly the kind of position where they'll be welded into the frame from the finished handrail. You can see there's a lot of variation in the shapes made by the reversal curves. When the units are actually welded together, they'll be placed so the individual curvatures fit in a pleasing manner, and also in a manner that will allow the required 3.5-inch spacing between the irregular uprights.